Hi, this is Brennan Baines in the Math Department at Lipscomb University, here to talk with you today about modeling with functions. In this app, we're going to learn how to use functions to model applied or real-world scenarios. Previously, in this app, we've talked about that functions can be used to calculate future values and that we can examine graphs of functions to make sense of applied situations. Some examples of doing this would include the following. Given the function p of t, which is equal to 3 times 2 raised to the 1/10 t, where p of t represents the population of a certain bacteria at time t given in days. We want to find the population after 100 days. So this would be calculating a future value. To use this function to do that, we simply would let t be 100 days. So we're finding p of 100. And when we substitute a value of 100 into our function, we find that there are 3,072 bacteria at 100 days. We also might look at a graph. This graph also shows the population of a certain bacteria t days after being placed in a petri dish. And so we might tell the story or describe the growth of this population of bacteria. You might note some other observations than what I mentioned here, but we'll notice as we'll toggle back and forth to the graph, at time equals 0, there are very few bacteria in the petri dish. And the bacteria population, of course, begins to increase. That increase is slow at first, but then it begins to get faster and faster as t increases. And we can see that on the graph as we look at the rise in the y values. We're 40 days out and we haven't even lifted up very much at all. We're not even to 100 bacteria. And then from days 40 to 60, we'll see we begin to jump a little more. And then from 60 to 80, the increase is even more, and so on. So the growth rate is increasing. Here's another example. John and his wife Sally walk around their neighborhood at 4 miles per hour. We want to write a function for the distance John and Sally travel after walking for X hours. So we might define d of x as the distance traveled after X hours. And again, X will represent the number of hours that John and Sally have walked. So we need an algebraic expression that relates time walked and distance traveled. We might begin by looking at an XY table just seeing what values we might see there. So if John and Sally have walked no hours, then they will, of course, have gone no miles. They walk at a rate of 4 miles per hour. So if they walk for 1 hour, then they will have traveled 4 miles. If they walk for 2 hours, they will have traveled 8 miles, and so on. 3 hours, 12 miles, and so on. So it appears the relationship between x and y is that y is always 4 times the x value. And so we might write our equation as distance, or d of x, is 4 times x. As we move on through the course, we're going to learn that this is a special kind of function. And as we study that special function in detail, we'd learn how to write this equation using the aspects of this special function versus coming up with the equation from an XY table. Now that we have an equation that relates John and Sally's distance traveled and the time that they spend walking, we can now answer questions like how far will John and Sally walk if they walk for 3 hours? Or questions like Sally wants to walk 10 miles. How long will Sally have to walk? Here's a second example. Bargains, Bargains, Bargains Incorporated is having a Super Saver sale on outdoor patio furniture sets. The furniture sets are 45% off of the regular price of $630. Bargains, Bargains, Bargains Incorporated are able to purchase these patio sets at a cost of $200 each. Write a function for the profit, we'll call it P of X, for selling X furniture sets. One way we might come up with this equation is to let X be the number of furniture sets sold, P of X be the profit for selling X furniture sets, and then we might just start calculating profits for actual numbers of furniture sets sold. So maybe for selling one furniture set. And so if one furniture set is sold, then the price that's going to be paid is 55% of the regular price. That's 55% since the furniture sets are currently 45% off. So 55% of $630 is $346.50. The profit made by Bargains, Bargains, Bargains Incorporated would be $346.50 minus the $200 that they paid for the furniture set. And so they've made a profit of $146.50. And that would be the profit that they make for each furniture set sold. And so seeing that, we can write the equation P of X equals $146.50 times the number of furniture sets sold, or times X. Now that we have an equation or a function that relates X and Y, we can answer questions like, what's the profit if 200 furniture sets are sold? Or we can also ask questions like, how many furniture sets should they sell in order to make a profit of $10,000?